Alright guys, we are now on the back page. So here we are on our next one. We're going to look at the square root of x, the third root of x, excuse me, third root of x minus 2, and then the third root of x plus 3, and all those are underneath. So here's the thing, guys. I'm going to go plot those in a Desmos, and I think I have them up already. So there is my parent function. So here's the thing. The minus 2, I'm pretty positive is going to move it to the right too, because if it's on side, it lies. So right there, I know it's moving to the right too. And then on this one, I went and I plotted it, and that plus 3 is making it move to the left, 1, 2, 3. So I know that's what's going to happen. I plotted them already. Let's go get it in our paper. So my parent function, set up to go. -8, -2, -1, -1, 0. 1, 1, and then I have 8, 2. And you guys have that in your notes. I don't have it up here on my slide, so let's go plot that. -8, -2, -1, 1, 0, 0, 1, 1, 8, 2. So I curve up, and then I curve what? Down. So here's the thing. My next function right here, that minus 2, we saw that it moved all my points to the right too. So I'm going to take each one of these points and take it to the right 2. 1, 2. We're going to go this one I'm going to take to the right 2. This one, 1, 2, I'm going to go right 2. That one to the right 2. And then over here to the right 2. And I'm going to go like this. And I'm going to come down. I realized I did those two super fast. So I'm going to give you guys a few seconds to get caught up with me. Okay, we're going to come, and right here I look, my y values are staying the same, but my x values are not. My x values got shifted by 2, so at 0, to get an output of 0, I had an input of 2. And then over here, 3, 1. Right over here, I had a point at 10, 2. So here's the thing. -1 went to a +1, -1. And so at that -2, I went over to a -6. My x value is a -6. So that -2 didn't change my y values. It changed my x values by adding 2 to it because it moved to the right too. All right. Next one, we got a plot. And we know we've already plotted it, it's moving it to the left 3. So I'm going to take each one of these parent points right here and move it to the left 3. 1, 2, 3. Move it. 1, 2, 3. This one, 1, 2, 3. That one, 1, 2, 3. This one, 1, 2, 3. And it's off the board. But my center, that part goes up, and then this part goes down. So my y values are going to stay the same, but my x values are not. Okay, so I got -2, -1, 0, 1, 8. I have it plotted. Things look awesome. We just need to go get the x values with that. So at 0, it was a -3, right? -2 to give me my 1. Over here, that was at a 5. So it's like I'm taking away 3 from x values. -8 minus 3 is a -11. -1 minus 3 is a -4. And that's what matches up with that one. So I have those, and I have those all plotted. So if it lies inside, it lies to us. I know you don't have this in your notes, but it goes left or it goes what? Right. So let's go talk about domain and range. For my parent function, right? My domain is all reals. My range is all reals. So none of those, right? My right side's still going up. This side is going down. Things look good. So it's all real. So everything is all reals, and I'm being lazy and I'm not writing this down. These notations mean the exact same thing, right? And that means the exact same thing as positive, negative infinity to a positive what? Infinity. Gonna give you guys like 10 to 15 seconds to kind of get some stuff wrapped up, and then we're going to the next one. Alright guys, so we're finishing off this really fast. So what is the difference in the graph when a constant is added outside the radical versus inside the radical? So after we talk about this, we're going to do some stuff in Desmos. If it's outside the radical, we know this because this is in function notation. We talked about it the other day. I'm going to move up, or I'm going to move. If I'm adding, I'm moving up. If I'm subtracting, I'm moving down. If it's on the inside, we know this. We go to the left or we go to the, and the main thing we need to remember with that, if it's on the inside, it's lying to me. If it lies inside, it lies. So we're going to go look at Desmos really fast and look at those two things. So my H value moves it to the left and the right. I've said that backwards as my graph. So as we go around, right, it's that center value right there that that center value, I gotta keep that in mind because it's the center point of the graph, right? And I have it like labeled for us. Okay. Alright, so now we're gonna come back here. We have this last one to do. So we have 4 of them we need to do on this one. So setting myself up with my parent one. I know this, my parent is going to be, this is going to be the domain, and this is going to be the range. So far, nothing has changed with that. So over here, -2, -1, 0, 1, 1, 8, 2. I'm going to go plot those really fast. Okay, going to give you guys like 10 seconds to cut up. Okay, here we go for the rest of this. My next function that I have is g of x. The difference between g of x and everything else that we've done, that 3 is doing what? It's multiplying. So when I multiply by something, tying it back in, when I multiply, I'm not going to move it left, I'm not going to move it right, I'm not going to move it up, I'm not going to move it down. I'm going to use this word that your class seems to love, dilation, right? So I dilate, but I dilate by 3. So if I'm dilating by a 3, that means I get bigger by 3, so I'm going to stretch it by 3. So here's the thing. That 3 isn't going to affect the input values. All it's going to affect is the output values. So here's the thing. If I put in a -8, third root of -8 is -2. -2 times 3 is a -6. If I put in a -1, third root of -1 is -1 times 3 is a -3. If I put in a 0, third root of 0 is 0. 0 times 3 is 0. If I put in a 1, third root of 1 is 1. 1 times 3 is 3. If I put in an 8, and third root of 8 is a 2. 2 times 3 is a 6. So I get those points right there. Okay? So 0, 0, 1, 3, 8, 6, -1, -3, -8, negative what? 6. And then I curve up, and I curve what? Down. So that's, like we plotted it, it stretches it, that's what it looks like, right? So here's the thing, the next one we're going to talk about. We have a negative, but it's out front. So negative out front. It's going to change my outputs, it's going to make all my outputs change, right? If it's a negative, it's going to become a positive. If it's positive, it's going to become a what? Negative. We're going to come over here and I'm going to show you what happens, right? So I have a negative third root of x. That's what that looks like right there. So it makes a reflection over the x axis. So I'm going to come back here and I'm going to plug in some values, right? So I got a negative third root of x. If I do a negative 8, these values are not going to change, but negative 2 will become a positive 2 because it's timesing by a negative. A negative 1 times a negative is going to become a positive 1. 0 will stay 0, but a positive 1 times a negative will become a negative 1, and then 2 will become a negative 2. So it flips. So negative 8, 2, negative 1, 0, 0, 0, right here, right here. So I curve up, and I curve down, and then there is that reflection over the x-axis. So we have one more that we want to look at. I have a negative on the inside. So I've got to remember what happens when I have a negative on the inside. So here's the thing, negative 8. If I put in a negative 8, that negative becomes a positive, so I get a positive 2. If I put in a negative 1, that becomes a positive what? 1. If I put in a 0, I should get out a 0. If I put in a 1, I should get a negative 1. And then I have this, 8, and I should get a negative 2. Oh my goodness, it looks like the exact same output as what we had right there. So I'm going to come here, I'm going to plot those points. And even when I plot those points are lining up on top of that one. They're all the exact what? Same. And I have this. It's going to change right there from that black. You see that overlap? So you guys, a reflection over the x-axis is the exact same as a reflection over the y. What happens is this part, when it gets reflected over the x, becomes this part. But then when it flips over the y, this part flips to become that part. But this is when it reflects over the x, that flips up to become the y. And so they have this, it's the same thing. So want to show you, right? So I can stretch, I can shrink, right? Stretching it or shrinking it. I can reflect, and I can reflect and stretch, reflect and shrink, reflect and stretch, reflect and shrink, reflect, shrink, reflect, shrink, reflect, shrink. And then, right, I have all this stuff. And my v value will just make it reflect over the y-axis. So, big thing that one does, it stretches it, right? Values out front when I multiply are going to stretch, or they're going to shrink it, or they're going to make it reflect. So my a value can make it stretch, it can make it shrink, it can make it reflect and stretch, reflect and shrink. So if it's a negative, we'll call it reflection, but depending on that value, you can stretch it or you can shrink it, right? So it's sad, all of that jazz.